I will talk about immutable classes today. Well, most of you might not know Java. I mean, this conference is mostly about .NET, so if you don't know Java, shouldn't be any problem. This concept of immutability is related to any kind of programming language. So yeah, there will be some examples in Java because my first language is Java, but the code is really simple, so you should be able to follow, I'm sure, without any Java knowledge, as long as you're a developer, of course. Okay. So, a few words about myself. My name is Markus Biel. I'm a clean code evangelist, a JCP member, and at the moment I work for Vodafone as a senior software developer. If you want to stalk me on social media, just Google my name, you should find me everywhere. And yeah, enough about myself. So, let's be quick because there is only 30 minutes for the talk. So, here's the outline. So I want to start with telling you what actually is an immutable class, okay? So, this is the Java Duke. For those of you who know Java, you should also know the Java Duke. So the idea of an immutable class is you create an object of an immutable class, and this class is not changeable, is solid, fixed like a stone, or just like this Java Duke here, right? So the question now is, if you have, like, as another example here, the USS Enterprise, and of course it's flying through space, so there's a lot of changes needed, right? So how can you do all these changes when you cannot change the object? For this, let's look into the code. So instead of changing the object, you just return a different or new object instead. The first parameter here is name. Well, the Enterprise will still be called Enterprise, so this is not going to change. And assuming we're flying to outer space, so we're setting a new destination here. Okay, so that in like 2 minutes is what an immutable class is. Now I want to tell you a bit about the advantages. Okay, so there are many, many advantages of an immutable class. So these are, in my opinion, only the most important ones. And the first one is immutable classes are really stable. So let's look what this means. So here you see again an image with a Java Duke going into a bank. So let's assume you're the lead developer of a great bank, and you all know there was the financial crisis, right? So the bank, they're smart guys. The business guys, they come to you and they say, hey, we need a new system, and we shouldn't allow any debt for our customers, right? Because in the financial crisis, the problem was that all the customers, they were running into a debt, so and couldn't pay back the debt. So now the smart business guys, they say, well, if we don't allow our customers to run into debt, then this should be fine and we're safe. Okay, so you as the lead developer come up with this first quick implementation. Not sure if that's production ready, but that's not the point here. So we will just write this little validation method, and whenever the balance is changing, we will throw an exception, right? So now in that system, of course, there's a lot of methods, because the bank wants to earn money, so they also offer a lot of services. So in every method here, the code is not shown, like withdraw, pay debt, and transfer money, you have to, of course, call this validation method. And let's assume 2 months later, there will be new functionality provided, or let's say a new developer joins the team. So whenever there is a new method, we have to remember to call that validation method. Now that is a bit risky, I think. And for me personally, as a clean coder, also is not so clean. So I just hope there is a better way with immutable classes. And it turns out there is, because the cool thing is immutable classes, immutable objects, they don't change, right? So all we have to do is we call the validate method once. And if the balance then is above 0, we're fine, because after that it's not changing. And that is cleaner, safer, also like a bit less code. So that's one advantage. The next advantage is immutable objects are also fault tolerant. Let's see what this means. For this, I've prepared this tiny animation. So again, we have the Java Duke typing his PIN into an ATM, and he wants to withdraw some money, but there's an error happening. No shit. Because the problem is, let's assume the money is already taken out of the account, technically, from the bank account, but the money wasn't coming out. So now the money is lost. Okay. I mean, money is a serious topic, because yeah, no one likes to lose money. So, I mean, I also worked in a financial institution, so this cannot happen, right? There are, of course, strategies to prevent that, with as well as without immutable objects. But with immutable objects, it's quite easy, because the thing is, the balance will never be zero in a case of an exception. And so we're safe. Let's see what this means in code. So here, I've again just a quick some code sample. So we see the withdrawal method, and a new balance is calculated down here. This is so far it's just empty, because the code isn't really important to us. The point here is an exception is happening, and the exception will bubble up all the way. So this yellow line here, this will never be executed. And this is why we will be safe. I mean, we can't cast magic, right? Because the thing is, of course, if the money is not coming, the money is not coming. But further damage of our system is protected. So the money of the customer is safe, and that is just coming out of the fact that immutable objects don't change, so you don't have to add any extra code here. Okay, so I think these two advantages to me are really like the most important ones. The next one is immutables can be shared freely, and that means both in a multi-threaded system as well as in a single-threaded system. Of course, the bigger advantage is in a multi-threaded system. There you would use, for example, a CAS algorithm, compare and swap. I could not fit that into 30 minutes, so let's just assume it's also safe in a multi-threaded environment, and that is also super, super fast, because you don't have to synchronize the objects there. But it's not easy still, okay? So we will look just at a single-threaded environment. And here you have two accounts. At the moment, they're sharing the same balance, because with immutable objects, that's fine. So when the right account changes the balance, this is not a problem, because the balance, there will be a new object be created. And so we will not influence any other account. Okay. And the last advantage is immutable objects, they work well as map keys and set elements. Now this is a bit Java related, I think. I don't know about like C#, because this is related to the interfaces in Java, where like the interface as a contract says, if you add a map key or a set element and you change it, the behavior is not guaranteed. So this might work or it might not work. We just don't know. It depends on the implementation. So to give you a concrete example, I've prepared here the example of a Java util hash map, right? So the hash map, as the name implies, is based on a hashing algorithm. Again, can't go into the details of the hashing algorithm, but what matters to us here is, let's assume there are 3 elements in the map, 3 entries, and we're adding a 4th one here. So the key is mutable in our case, it's just a color object, and the value is just an animal object here, in this case a blue elephant. Now, we're changing the key while it's in the map. So far, everything is fine, no problem. Now the problem is when we try to retrieve that same entry. And we could even use the identical key. And that looks like, hey, the identical key, I still have a reference to that object, should be pretty easy to retrieve it. Well, in a hash map, it's not. Because the position is calculated, and so it would, for example, expect that object to be here in the white area. So that means it would not find any object. That's bad, but it could be worse. And that would be we find a different object. Worse because, like, imagine we're going back to the example of money, and you wouldn't so easily find that bug. Because, for example, you have 2 customers. One is the rich, I don't know, Bill Gates, and has $2 billion on his account. The other one is just you or me. Now, if you get, of course, all the money from Bill Gates, you will probably not go to your bank and say, hey, there was a problem, right? So it might be that this takes like 2 months or, I don't know, days until it's found out, and a lot of money would be lost. So this is really bad. And so now, of course, again, can be done with mutable keys, as long as you're like ensuring that the key is not changed while it's in a map or in a set. But you know, I mean, we developers, no one is perfect, and with immutable objects, it's just safe. You can't do it wrong. Okay. So now that we looked at the advantages, let's also look at the disadvantages. And to be honest, there's not many disadvantages. There's maybe just one, and that is immutable objects may, and the may here is important, may lead to performance problems. Okay, let's see what this means. So we have an object, right? And I said, for every state change, we have to create a new object, right? So if there is a lot of object state changes, we need a lot of objects, right? And every object, of course, uses a tiny bit of memory, not much. But if we're speaking of millions of objects, which quickly can happen if there's a lot of state changes, that can be a big problem. Okay. But to give you another example, I mean, this really depends, and I can't easily tell you this is good or bad, right? I would say in the majority of cases this is fine, because memory these days is not that much of a problem, right? And then also it depends on the number of state changes. Like this is a super simple example with one traffic light, which just has 3 different states: a red color, a yellow color, and a green color. Now, each time, let's say on a day, there's 1,000 different times the color is changed, you would then create a new object, dispose it, create a new object, and so on. Well, maybe that's not so smart, right? Instead, we could just create 3 objects, put them in cache, and then all we have in cache is 3 objects. So this is super fast. We just have to switch between the 3 different objects, and then we're fine. But of course, it depends. We don't know if this is working or not, because we don't know how many states there are, so this has to be tested. So I want to leave it here, because the performance discussion is a big thing. I'm just saying that this might be a problem, and the majority of cases is probably not. Okay, and now I want to tell you how to create an immutable class, step by step. And there are 4 rules that you have to follow. I try to sort them like starting with the easy stuff. And the first one is you make all attributes private and final. Again, going to the code. So we have our immutable spaceship class to keep it simple and also clean. I mean, it's nice to have a small, clean class. We just have 2 fields, private final string, name, and private final destination. So of course, we make them private. I mean, everyone, like this is, I guess, clear for everyone to make fields private. Here, for the immutability, we make it private so that no one can directly access the field and change it. But of course, let's say the enemy is not only outside, it's also possibly inside the class, because of course the new developer joining the team, and let's assume the class is not so clean like here, only a few lines, but much longer, might think it's a great idea to assign a new value to destination later on. So to prevent that, we also make it final. So that then fields can't be changed after they have been set on the constructor. And then also, this is documenting what you want, right? Because for me as a clean coder, it's really important that this should be self-documenting, right? So by using final, you also say something to the next developer, hey, don't touch my code. Okay, so the next rule is the one that I already showed you in the intro. So that should be really easy. You should not provide any methods that modify the object state. So here again, we see exactly the same example as from the introduction. We just return a new instance. Okay, so I think that's clear, so just jump over that. And the third rule, now this is a bit tricky. I wrote an article also on DSON about that, and many did not understand that. And so please listen carefully. It's not so easy to understand maybe. This time I really tried to make it as super clear as possible. The funny thing is, like, when you see this example, you might think, hey, why is this a problem? This is so super easy to understand. Because of course, I'm making here super simple examples. But it turns out, like, if you get it wrong, you're in good company. Josh Bloch, who wrote big decimal and big integer, initially when Java was coming out, they did it wrong. Both these classes can be extended. They were intended to be immutable, but because of this fact, they're not. So, of course, they're aware of that, and they would want to change that, but on the other hand, they also want to be backwards compatible, so this is why they're not changing that, and we just have to live with it. Which is fine. I mean, there is a difference between real immutability and effective immutability. So as long as no one extends the class, everything is fine. It's just a bit unsafe, right? But let's see this more in detail. So, following along with my Star Trek example, I thought, hey, the Romulans are the evil guys, right? So they are now trying to destroy our immutability. So of course, they extend the immutable spaceship because so far this is possible. So next thing they do is they add 2 new fields, an evil name, an evil destination. In my original example here, I had just said name and destination, which is also possible, but it's a bit confusing because you should understand these 2 different new fields. I mean, we're extending immutable spaceship, and this one has private final name and private final destination, right? But these fields are private and final, they're not seen. So it is as if they would be never here, as long as we don't provide any getters and setters. So the name can be anything. The point is that we have new fields, and we will, in the 3rd step, abuse them to store the state, to make it mutable again. So this is the 3rd step. We're overriding now the new destination method that receives a destination reference. And instead of what we always did before, returning a new instance, we're directly assigning that to our evil destination. And of course, the signature of the method forces us to return an object, an immutable spaceship object. But as Romulan spaceship extends immutable spaceship, that can be done. So we just say return this, and we have like properly overridden the method, yet still it's now mutable. And this, of course, has to be prevented. Well, that's super easy. All we have to do is make the class final. There are, of course, again, other ways to do it. You could, for example, provide, you could make all the constructors private, and then just provide a static, public static factory method. You could also make all methods final. Again, not so stable maybe, because as soon as another method is added, so not so nice. So the easiest way is just you make the class final and you're done. Okay, so, and now the point is, so far we were assuming that the name, which is a string, no, that's not an assumption, string is immutable by definition, coming from the JDK. Destination is just a custom class that we wrote, and of course I didn't show you the source code, because I was just making an assumption that it's immutable. But we don't know without seeing the source code. So, on the assumptions that all the fields are immutable, we're done with rule 3, and we have successfully created an immutable class. But on the assumption that one of the fields at least is mutable, we have to continue, and we have to ensure exclusive access to any mutable attributes. Okay, so here again, to illustrate this, our spaceship, as I said, name is immutable still. So if there is any other mutable object coming and trying to change that, it's not working because it's immutable. So we are safe. Now with destination, on the assumption that it is mutable, that's not so safe. If anyone can get a direct reference to destination, that other object can change our destination. And then of course our so-called immutable is not so immutable anymore. Okay, so this we have to prevent. And how can we prevent that? We must not allow that anyone can get a direct reference to that destination reference or any mutable attribute we have, right? Instead, we deep copy. Whenever we want to access a mutable field, we provide a deep copy of that. So now we created a distinct, a new destination object inside of our mutable object, and we're safe. Because when that is changed, of course we have a new object, and this will not have any consequences to our immutable. Okay, so this is the idea, and we do the same thing now in code. So to do this, all the public constructors and the public methods are like the entrance doors to our object. Those we have to check, right? It's like the security points. So we start from top down, and just 3 stupid simple examples. On the top, the public constructor. So it receives a string name. Name is still immutable, so this is not a threat to our immutability. And then we see in the second line in the constructor, there is a new destination created. But the reference is still safe with us, right? The constructor will not return any reference to destination. So this constructor here, as it is safe. By the way, you might notice before, I created destination by just using a static constant. For example, it could have been an enum, so to indicate this is an immutable. Now I change the constructor here to indicate, hey, now this is a mutable object. But without seeing the source code, of course, it's just an assumption. But anyway, this is safe. So, next one, public current destination. So this does not receive any parameter, that's good, but it returns the reference to destination, and that's not so good. Because now, anyone who calls the method and directly has a reference to destination and can change it. So we must not allow that. So instead of returning directly destination, we return a deep copy of destination, and then we save again. And the last one is that new destination method that we looked at before. So here, we are receiving a destination reference. So what do we do with it? We create a new object. So far, there's nothing really I can see that is a problem. But of course, we're not done yet. We have to follow the path of that reference. What is happening with that? So we're calling a constructor. So let's go to that constructor. It's private. So we didn't look at it before because it's private. But now, transitively, we're calling it. So now, it seems like we have to check that. And we see, again, the destination is directly assigned. So that is a problem. But just the same is easily fixed. All we do is we create a deep copy of the incoming destination reference. Okay, so if you follow these 4 rules, you're done. You have created an immutable class. Okay, and now, I want to come to a conclusion. So I showed you all the advantages of an immutable class. And I hope you understood that they can really make your life better because they provide a lot of stability, right? At the cost of a risk of potential performance problems. So this has to be checked. I mean, in 9 out of 10 cases, performance these days with super fast service is not an issue at all. Then you're safe. So I would only dig deeper if you see performance is an issue, we have to be faster, and then of course you have to test the performance. So if you find out A, performance is a problem, B, what is actually the problem, right? I mean, you have to find out we're creating too many objects, and we're creating too many objects because we're using too many immutable objects. And then you have to lower immutability as much as needed. But of course, still use immutable classes as much as ever possible, because also from a clean coding perspective, to me, immutable classes is what object orientation should really be, right? Because they truly enforce encapsulation. I mean, they don't provide any true getters and setters, and also you will only be able to create an immutable class if it's simple. If there's, let's say, 10, 20 fields in your class, and you have to throw them all in one constructor, right? Then your constructor will grow heavily, so this will not look good, and you will already feel, no, I don't want that, right? So this will lead to simple classes. So immutable classes lead to clean code, and clean code helps you make classes immutable. So they are a well-matched pair. And this will lead to a clean architecture. So thanks, that's it.